Here are rational expressions. We're going to simplify this expression. The first step, when you have this, factor everything, and then you're going to cancel the common factors. Remember, cancel binomials with binomials, monomials with monomials. You cannot cancel terms. So we have x minus 6 over x squared plus 4x minus 60. What this means, you can't cancel the 6 with the 60, the x with the x. You can't do that. It has to all go together. On the top is a binomial, on the bottom is a trinomial, so there's no way you could cancel that. But if we factor the bottom, so the top is x minus 6, we can't factor it. But if we factor the denominator, notice we're going to factor like we did in the problems 7:13 through 20. Look for the greatest common factor. There's nothing there. It's in order. We're going to have x times x gives us x squared. The last term is negative, so the signs will be different. We know in numbers that multiply to give 60, and that's a negative 60, but subtract to give a 4. So 1 and 60 doesn't work, 2 and 30, 3 and 20, 4 and 15, we're getting close, 5 and 12, 6 and 10, and there we go. So if we multiply those together, we'll get a 60. If we subtract them, we'll get a 4. Now we want it to be a positive 4, so it needs to be a negative 6, right? Negative 6 plus 10 is positive 4. So negative 6 and 10. So we can check that in our head. X times x is x squared. Negative 6x plus 10x gives us that positive 4x. 10 times negative 6 is negative 60, so that checks. So now we're going to cancel common factors. So binomials with binomials. This up top is a binomial, x minus 6. This is a binomial, x minus 6. It has to be a 1-to-1 ratio, one on top, one on bottom. So now to write our answer, when it cancels, it goes to a 1. We just don't write the 1 because it gets all, with all the 1s putting there, that would look confusing. But we know in the numerator, it's a 1 because everything canceled. In the denominator, it's just x plus 10. So our answer is 1 over x plus 10. This one, we're multiplying. So it's very similar to the one before. It's just we have another fraction and we have more to cancel. So we're multiplying. And notice in the problem, they give us the expressions to multiply, and then they say x is not equal to 3, 1, and negative 2. That means if for some reason they told you x was 3, you couldn't work it because you would get a 0 in the denominator. And you can't multiply, divide, you can't have a 0 in the denominator. So that's just extra there. You don't have to do anything with it in this problem. So I'm going to factor everything. Let me just rewrite. X squared minus 1 times x squared minus x minus 2 over x squared minus x minus 6. All right, let's start with the numerator and the first fraction. X squared minus 4x plus 3. There's not a greatest common factor, so nothing to factor out. It's in order. It's 3 terms, so that's going to be, oops, sorry about that. Well, we'll just go from there. That's going to be x times x is x squared. Last term is positive, so signs are going to be the same. They're both going to be the middle term, negative. Factors of 3, 1 and 3. So if I multiply that and check it, x squared, negative 3x, negative 1x, those combine to give me a negative 4x. Negative 1 times negative 3 gives me a positive 3. So if you check with FOIL, you'll be good. Now, the bottom, that's 2 terms, and it's the difference of 2 perfect squares. So it will always factor. Take the square root of x squared, the square root of 1. So square root of x squared is x times x. Signs have to be different because it's a negative 1. Square root of 1 is 1. And if you check that, the inside and outside will cancel out, and it'll go back to x squared minus 1. All right, second fraction. Numerator, x squared minus x minus 2. Nothing common. It's in order, so x times x. Last term is a negative 2, so the signs have to be different. And the only factors of 2 are 1 and 2. So we want 1 and 2 will subtract to give us that negative 1x. So we need it to be negative 2 and a positive 1. Now let's double check that with FOIL. X times x is x squared. First term checks. X times negative 2 is a negative 2x. And then 1 times x. So negative 2x and 1x gives us a negative x. So that checks. And then 1 times negative 2 is negative 2. So the last term checks. Second fraction. Denominator in the second fraction. Nothing common. It's in order. X times x is x squared. Last term is a negative, so we know the signs have to be different. We're looking at the last term to decide what the signs are. Then two numbers that multiply to give us 6 and subtract. Because the signs are different, subtract to get a negative 1. So 1 times 6 would subtract to give us a 5, but 2 times 3 would give us a 6, and we want it to be a negative 1, so that would be a negative 3 and a positive 2 would give us a negative 1. So put 3 there and the 2 there. Again, we can check with FOIL. X times x is x squared. X times negative 3 is negative 3x, and then 2 times x, 2x, that's a negative x. 2 times negative 3 is negative 6. So now what we're going to do is we're going to cancel common factors. Remember, binomials with binomials, monomials with monomials. Good thing, everything's a binomial. So I have an x minus 1 on top, and I have x minus 1 on bottom, so that cancels. I have an x minus 3 on top, and I have an x minus 3 on bottom. I have an x plus 1 on top, and a x plus 1 on bottom. I have an x minus 2, but it's an x plus 2 on bottom. Those are not exactly alike. They're not exactly opposite. The 2's are opposite, but the x's are not, so you couldn't reduce it. So our answer is going to be x minus 2 over x plus 2. Now, how they want you to write this is weird. I think this is the one where they have you put the numerator up here. So you're going to put x minus 2 up here and x plus 2 down here. I think they have you put it in two different spots for some reason. Yeah, they have you enter it separately. Next one. Now this is similar to that other one, except it's division. So we're going to factor everything. Remember, you change division to multiplication and you flip the second fraction, just like with normal fractions. And then we're going to cancel any common factors. So I'm going to go ahead and start with that first fraction. I'm going to factor x squared minus 49. There's nothing common to take out. It is two terms, and it's the difference of two perfect squares. Now, this is the shortcut you just want to memorize because you're going to get it a lot. Where you have the difference of two squares, you take the square root of the first term, square root of the last term, and your signs are always going to be different. So it's basically the same thing, except one's a plus, one is minus. When you check it with FOIL, the inside and outside cancel. All right, denominator. It's a trinomial. There's not a greatest common factor to take out. We know we're going to have x times x is x squared. Last term is a negative, so we know that's a negative 7, so we know our signs have to be different. We want to multiply to get 70, and then subtract those numbers to get a 3. So if you think about it, 7 times 10 equals 70, and if you subtract 7 minus 10, you'll get a 3. But we want to do minus 7 plus 10, because that will give us a positive 3, and that's what we're wanting. So that means this will give us a negative 70. So we want a negative 7 and a positive 10. And double check yourself. Again, with FOIL, it helps you learn where the numbers go when you do FOIL. X times x is x squared. X times negative 7, that's a negative 7x. And then 10 times x is 10x. That gives us a positive 3x. That's what we wanted. 10 times negative 7 is negative 70. So now we're going to change this. I'm going to put a star here. Change it to multiplication and flip our second fraction. So x plus 10 goes on top and 3x goes on bottom. And the thing here is there's nothing to cancel because, or nothing to factor, because x plus 10 you can't factor, 3x you can't factor. So now we're going to cancel. Remember, we cancel monomials with monomials, binomials with binomials. So I start at the top left. That's an x plus 7 on top. I have an x minus 7, but I don't have an x plus 7 on bottom, so nothing there to cancel. This x minus 7 will cancel with this x minus 7. Then I have an x plus 10 binomial and an x plus 10 binomial. Now I have a monomial of 3x, but I don't have a monomial on the top. So my answer is x plus 7, because that's what's left, over 3x. Now do not cancel the x's, because up top is a binomial, on bottom is a monomial. In monomial, it's 3 times x. Up top is x plus 7. So you cannot cancel them. This would be our answer. Oh, and they want this one in separate boxes also. So x plus 7 and 3x. If you happen on a problem like this, you happen to get a 1 on the bottom, normally when you write your answer, you don't need 1, but if it's asking you to put the denominator in a box, make sure you put a 1 if it's a 1. And I think they remind you of that there.